Researchers noted that in the absence of a reducing agent, the elution time of a certain protein from a size exclusion column decreased considerably relative to the elution time when the buffer contained a reducing agent. Which type of molecular interaction was responsible for this observation? So, with size exclusion, aka gel filtration chromatography, right, which is what they're describing here, elution time is inversely proportional to size, right? Where the smaller proteins, okay, the smaller the protein, the longer it's retained in the column, okay, and so the longer the elution time. Whereas the larger the protein, the shorter the elution time. Okay, so remember that. So the only way that the elution time of the protein was actually longer when the reducing agent was present is if that protein was somehow smaller, okay? Now, what does a reducing agent do in the context of proteins, right? Well, it can reduce disulfide bonds, which commonly hold together subunits of a quaternary structure, which means that if we had, for example, if this protein was like a homodimer, where you have two identical subunits held together by a disulfide bond, and let's say it weighed 100 kilodaltons, then clearly if, we added a reducing agent and we cleave this bond, we would get two subunits that each weigh 50. And so if we compared elution times between these two situations, the 50 kilodalton subunits, by virtue of being smaller, would stay in the column for longer, whereas the intact quaternary structure, because it weighs more, will be eluted quicker, right? And so this completely explains this observation, because if you don't have a reducing agent, this remains intact and elutes faster. But if you do have a reducing agent, that breaks this bond, and you basically produce two smaller subunits or more smaller subunits. Again, this is a hypothetical example, but those smaller subunits will be retained for longer, right? So D has to be the right answer. The molecular interaction responsible for this has to be disulfide bonds, because those are the ones that are actually affected by reducing agents.